everyone. Good afternoon, and welcome to the second half of DSF May Day. My name is Chidima Akwada, and I'm your host for this session. Just a few announcements before we kick off. After today's final session, we'll be networking at the Spades Bar downstairs from 5 to 6 p.m. So please hang around to meet the speakers from today and network. Our next speaker is Clemens Schroeer. And Clemens will be delivering a talk titled Data Curation for Open Source LLM Fine-Tuning. Clemens is the co-founder of Lemon AI, a data curation solution for LLM fine-tuning. Previously, Clemens was the co-founder of a data observability startup, helping data engineers to detect and resolve data anomalies. Please join me. Welcome, Clemens.
Thank you. Can everybody hear me with this thing? Okay, cool. So hi, my name is Clemens. I'm the co-founder of Lemon AI. At Lemon AI, we do data curation for LLM training and fine-tuning. So we help companies to actually build the best data sets, get the best results from fine-tuning and training. And today I want to share some of the data curation learnings that we've been able to make through our projects, where we essentially help companies to replace proprietary LLMs with open source alternatives. I'm from Germany, and as you already know, before I worked on a data observability startup, so I do understand a little bit about how high quality data is supposed to look like, and I'm very familiar with the modern data stack that I'm sure exists in many of the companies you work at. And yeah, we started Lemon AI earlier this year. We really got excited about this space when Meta launched Llama 2 in July last year, which was like the first very powerful open source LLM. And since then, it was, at least to us, very clear that long-term open source LLMs would win over proprietary ones. So that's really why we're so excited about this space. Before we talk about data curation, and by the way, when I talk about data curation, we have a so we will definitely focus on different data modalities over time, but for now we just focus on text, so everything I'm saying is kind of text related. But before we talk about data curation, let's zoom out a bit and ask the question, like, why would anybody be interested in fine-tuning an open source model in the first place? By the way, has anybody here fine-tuned an open source model? Okay, somebody here, great. Okay, so some people who can challenge me in the Q&A, that's great. But in many cases, companies realize as soon as they move beyond the initial experimentation phase that proprietary LLMs can be pretty expensive, inaccurate, and slow. And often there are some privacy concerns as well, because of course you have to send data to a third-party vendor, and many companies, especially in regulated industries like financial services and healthcare, aren't really comfortable with that. The beauty of open source LLMs really is that you can fine-tune them to specific use cases and actually outperform proprietary LLMs in terms of accuracy, cost, and speed. And of course, in addition, you get the privacy benefits because you own this entire setup, so you don't actually share any data with a third-party vendor. This has only been possible recently with the launch of Llama 2 and Mistral 7b. So here you can actually see that even today, you can outperform a model like GPT-4 Turbo when fine-tuning these two models. And the performance gap to proprietary LLMs is really just closing. Recent research shows that there are diminishing returns when you look at the frontier models. So at least our view is that fine-tuning really is the way forward for companies to maximize performance from LLMs, because I think the next iterations of major foundational models won't be that mind-blowing. But the big problem is, because you must be wondering, okay, why isn't everybody doing this, right? Like, why isn't everybody just fine-tuning open source LLMs already today? And the big challenge is that most companies don't have enough high-quality data to get great results from these models. And what I find really interesting is that, I'm not sure if you guys saw the recent release of Llama 3 by Meta, but that was a model, or that is a model that got kind of overfitted in a way. So they trained way past chinchilla optimal. They used 15 trillion tokens. So it's like they used much more data than you would have expected for training. And the future we really see is that enterprises train an entire portfolio of audience and task-specific LLMs. And I think the future will be that companies will need a lot of data to essentially overtrain even 1 to 3 billion parameter models. Obviously, it's best if that data is very, very high quality, but it's also about having a lot of data. So this is the core bottleneck today, and it's the reason why many companies, of course, haven't fine-tuned so far. When looking at a data set, there are a bunch of questions you want to answer. So when you start the data curation process for fine-tuning, you really want to be able to say, okay, is all of this data actually relevant to the task at hand I'm fine-tuning for? Is it correctly annotated? Is there any PI data that I should mask? How diverse is the data actually? So all of these questions you essentially want to find an answer for before you start the actual fine-tuning work. Apologies in advance, this slide is very text-heavy. It doesn't look so nice, but I will try my best and make it clear. So how can we actually achieve explainability? How can we get a deep understanding of dataset characteristics when doing this data curation process? And at Lemon AI, we look at a bunch of different factors. Broadly speaking, it's distribution, consistency, and diversity. Of course, there are others, but I think these are the most important ones. A good starting point is to actually understand what am I looking at, right? Like which topics are actually represented in the data set I'm looking at. A great way to do this is to actually embed your text, use UMAP to reduce the dimensions, use HDB scan to come up with clusters, and then use an LLM to actually look at what's inside of the clusters. This gives you a really strong understanding of what's inside your dataset in terms of topics, and you can try, hopefully, answer the question of like, is it actually in line with the fine-tuning objective that I have? Another really big thing is duplicates. So understanding where there are duplicates you should get rid of is really powerful, because you would be surprised in how many duplicates actually exist. Cosine similarity is a great way. It's essentially just a semantics distance measure. It's a great way to figure out where such duplicates exist, and identifying those and getting rid of them is really powerful. Be a bit careful, however, that you don't kind of overdo it. You don't want to get rid of too many input-output pairs as part of this kind of cleaning process. But of course, you can also, by the way, look at syntax and diction here. A big one is biases. So we spend a lot of our time to understand how over or underrepresented topics actually are. And this has huge implications for the extent to which you can actually or should work with synthetic data. We'll talk about synthetic data in a minute. But understanding where there is a certain bias is really key. You can also zoom in a bit and not only look at topics, you can of course also look at the choice of words, for instance, or the structural biases that exist in your text data. And then last but not least, as part of this process, there's of course maybe even data that just shouldn't be part of the data set. Maybe there's data that's PI data, so like a name or an address, something like that. You might want to mask that, especially if you're in like financial services, healthcare. Yeah. This is one way to visualize this. I just included this as a screenshot. This is something we built as it's like an early version of our front end. You're actually looking at duplicates here, and on the should probably stay here. So on the right-hand side, you actually see these grayed out bubbles, and these are just duplicates we removed. So building such a visualization on top of your topic analysis is powerful. So you can like do very granular work and see, as you kick stuff out, how the data set kind of evolves over time. And this is another example here. We've kind of built a screen where you can essentially compare two data points and then say which one you want to keep and which one you want to throw out. And this can be really powerful, especially for fine-tuning use cases. When it comes to training, this kind of visualization becomes a bit less handy just because the data sets become so large. So in such a case, be a bit careful with visualizations. But yeah, in general, it can be very powerful, especially if you want to kind of tackle a specific quality issue. Synthetic data is something that has obviously been around for quite some time. I think what we found is that LLMs have a kind of never seen before contextual understanding. So they can actually be very, very powerful when it comes to synthetic data. And we work a lot with synthetic data to solve this problem of data sets being too small. As I said, like most of the companies we've worked with actually have this problem. And as you can imagine, especially when it comes to training an LLM from scratch, this is a big, big problem. And you're essentially forced to work with synthetic data. Synthetic data can be especially powerful when you want to address very specific data quality issues. So, for instance, a topic underrepresentation, right? You can address that by creating synthetic data in a very targeted way. And also, you can just augment the data set to make it much larger. However, one thing I want to stress here is that when you work with synthetic data, be very careful that after each dataset iteration, you understand the impact on the data set. So for instance, you don't want to mess up your distribution after like 2 iterations. So try to kind of do it in a holistic way. I have 5 minutes left. Okay, thanks. Be aware that proprietary LLMs aren't that great at generating synthetic data. We've actually been surprised. We've worked with, for instance, GPT-4, how bad, for instance, the diversity really is. So you get, when you kind of look closer, you see that sentence structures is often extremely similar. And kind of it looks good, but if you then look closer, it's actually not that great. So be a bit careful. One approach to address this is to actually fine-tune an open source LLM just for synthetic data generation on a task level. This is what we do a lot. And what you can also do is you can use a second LLM essentially as a judge to look at the output generated by such a fine-tuned model to see how high quality the data actually is. But yeah, don't use synthetic data blindly. It's important to actually have this visibility. Just a couple thoughts on like post deployment things. So what we have seen is that companies, once they go through this data curation work and they fine-tune something like Mistral 7b, often they want to make sure that actually they can kind of curate data sets over time and have a continuous fine-tuning workflow. So think about how you can set that up in the context of your organization. And maybe you want to have like a kind of drift pipeline at the source and the output level, so you can actually detect when a certain bias, for instance, is introduced. I mentioned this before, but I think the future really will be that enterprises will have an entire portfolio of task and audience-specific models they will want to continuously fine-tune. I know it's very early, but if you're doing this kind of stuff, think about how this may look like in your organization, because I think eventually this will really build up the defensibility of your organization, right? Like building a data moat will be key, because most people will have access to powerful LLMs. It's not really what will differentiate you. Yeah, that's it from my side. Thanks so much. Feel free to email me. That's my email, or find me on LinkedIn. And otherwise, I will also be around after this talk. So yeah, let's chat outside. Thanks so much.
Do we have any questions? Clemens?
Can you tell us a little bit about how you generate synthetic data? How would you go about generating it?
Yeah, sure. I'm happy to. We haven't really, just to be super transparent, right? We've been working on this since the beginning of the year, so it's not like our solution does this in a fully automated way yet. We're still doing it on a project-by-project basis, working closely with our customers. The big challenge when it comes to synthetic data is that it's very domain and task specific. So I couldn't just fine-tune some model for synthetic data generation, use it for one project, and then like the next week I use it for a different one. That's very challenging. The approach we've taken to this is that the solution we want to build is one where essentially you show up with some sort of seed data set, and we, just for you, fine-tune an open source model to then create very tailored high-quality synthetic data to you. Obviously, part of the solution will be to have a bunch of checks, for instance, an LLM as a judge, to actually make sure the data is very high quality. And then a big part of this is also offering explainability capabilities, so you as a user can actually tell, okay, this is what I needed, right? This is going in the right direction. It's actually improving the quality of the data. As I mentioned, we've worked with, or we've tried proprietary LLMs as well, and we've really struggled to get high quality data out of them, just because if you look closer, often for instance, the structural diversity is really poor. So that's been our approach. I guess there are also others, but that's how we've been thinking about it. I hope that answers the question. Cool.
One more question.
How do you check your quality, or how do you measure your quality of this data?
Of the synthetic data?
No, this data which you have, which you get.
Right.
How do you measure quality?
Yeah, great question. So, first of all, we have a very kind of visual approach to this, right? I didn't show it because most of this stuff actually exists in the backend today, but the idea really is when somebody shows up with a seed dataset, to first of all give them a very deep understanding of the dataset characteristics. And it's pretty much along the lines of the stuff I've mentioned in this very text-heavy slide, where we look at, for instance, which topics are actually present in your data, whereas a underrepresented, for instance. If you think of a customer support chatbot, maybe a certain product comes up again and again, and the likelihood of this being overrepresented is quite high. So we want to show this, or we want to make it very obvious to you, while also obviously highlighting more micro quality issues, like maybe a certain word is like choice of word is very similar. So essentially it's along the lines of distribution, diversity, and consistency. And we hope that based on that, people will then leverage synthetic data to address quality shortcomings and also make a data set larger. I think you should never use synthetic data without having such deep explainability. That's what we tried actually early on when we helped a bunch of companies to replace proprietary LLMs. We were forced to use synthetic data. We didn't have the explainability, and we really struggled to tell, okay, is this actually making it better or worse? It's very challenging to say, because the synthetic data on its own, it might look quite good, but then if you combine it with your seed data set, it's not immediately obvious how it impacts, for instance, the distribution. So very heavy focus on creating this initial kind of explainability, visibility, so to say. Yeah.
Sorry, due to time, we can't take more questions. Well, Clemens will be outside if you have more questions.
Yeah, I will be.
Yeah. Thank you, Clemens, for the very
Thanks so much.
questions.